And basically, you're taking not any food, whether it be lipids or proteins or nucleic acids, can be converted into sugars to be burned during cellular respiration, or they can be channeled into, like a Krebs cycle down here, I haven't shown you, directly, do a little modification. But the big bad process is simply sugar burned in oxygen, yields carbon dioxide and water, and energy. And the energy is in the form of ATP, which we have learned about. We've talked about it. I described how it was formed in chapter, I believe, 1 and 2. Mm-hmm. So that's what we're trying to do. Now the numbers of ATP produced from one glucose molecule, it varies according to the book. It'll vary from 32 up to 38. So the overall number, I'm not really too impressed with, nor am I going to expect you to know the exact number. I would expect you to know it should be in the 30s. I don't know what teacher you're going to get in micro, and they're going to use a certain number, and you'll probably have to memorize it the way they do, so I don't want to corrupt your mind on which part else has this. So I don't know for sure, because I don't think anybody does. So we're just let it go. It's going to be in the probably mid-30s. I've always taught 38 when I was teaching this to the total number of ATPs. I just said 38, and then they started jumping around on me, and so I figured, what the heck, it isn't worth it. They don't know what it is either.
Overall number of blood?
I don't think it's going to make a hell of a big difference in your passing nursing school. So, the first thing we're going to do is to look at this glycolytic step. I'll come back to this one, but I think it'll be better for me to come back once we have gone through the whole process.
So this number, what is it?
Here is
okay,
the process
38 moles.
in its entirety. And you can see that we start off with glucose, and we're going to go through glycolysis. And in glycolysis, you're going to net, you'll net 2 ATPs. Because you start with, you make 4 ATPs, but you have to go endergonically. You have to use 2 ATPs to get 4, so you net only 2 over here.
What page is this?
So the overall process of cellular glycolysis, you are going to produce the following: 2 ATPs net, pyruvic acid, and 2 hydrogen carriers. And those are in the form of NADs, the NADHs. So that's really all that I'm going to teach you. As far as what you get out of the process. Now, where does it take place? In the cytoplasm of the cell. The more active the cell, the more it's going to happen. Fat cell, very little. Muscle cells, a lot. Enzymes will be used in the process. And you will not need oxygen for it to occur. It is anaerobic. So these are the anaerobic processes. I'll summarize them again later. All right?
Honey spray and rub.
Well, now you have two choices, basically, with your pyruvic acid. We've sent glucose through this series of changes, chemical changes, and now we've got pyruvic acid. And if you process pyruvic acid, it's got to go into the mitochondria of the cell. See, that's chapter 3. ATP was chapter 2. The production of ATP we talked about in chapter 2. Now, for you to get the pyruvic acid into the mitochondria where it can be processed aerobically, that means in the presence of oxygen, it's got to go through a process called decarboxylation. And this is how that's going to happen. From glycolysis, you have pyruvic acid. Right? And it won't go into the mitochondria. It chemically is not capable of getting into the mitochondria where it will be processed on the crispy. So it's going to be picked up with, the pyruvic acid will be picked up by coenzyme A. It's like a truck. It's like trucking things in. So the coenzyme A picks up the pyruvate, and when it combines together, it forms acetyl coenzyme A. Now, in that condition, it can go through the mitochondrial wall. So it passes through the mitochondrial wall, and now it's inside. And it will be disassociated into citric acid. And coenzyme A. It's just a cycle. That molecule is just recycling the pyruvic acid. But now we've got the pyruvic acid inside the mitochondria on the crispy as a very complex molecule called citric acid. Thus the name, the Krebs citric acid cycle. So once inside, we have the Krebs citric